Okay, example number 3, we're going to look at a circuit of 9 direct flush valve water closets on a branch. And we have a flush tank water closet on a downstream branch being wet vented through a lave. So where those two fixtures on this vertical branch drain past the branch connection for the circuit vented direct flush valve water closets, because the flush tank is 4 and the lave is only 1, at this connection we're only going to have 5 fixed units in total draining through here. So this solar waste pipe, the branch and the fixture drain wet vent, will both be able to meet the requirements of acting as our relief vent. So we're going to be able to use this solar waste pipe instead of installing a separate dedicated relief vent. Okay, so here's all our names. We've got the main branch itself. All of these trap arms, 9 of them, are connected to the branch. The most upstream one has the circuit vent originating from it. And this system down here we're going to use again as our relief vent. So the fixture drain for the lave is acting as a wet vent directly for this flush tank water closet. All our loads will take from, again, table 2493. Lave will go with minimum 1. Direct flush valve water closets are all 6. So at the most downstream circuit vented fixtures connection, we have 54 fixed units draining at that point. The next available pipe, drain or vent, downstream of this connection needs to meet the conditions of acting as a relief vent for this system, which this branch, draining past our circuit vented branch, will meet that requirement. No more than 6 fixed units draining at that point. We'll just make sure that it meets all the requirements as a relief vent for this system as well. Okay, so 54 is the total on our branch that's draining there. We have another 5 fixed units being picked up from these 2 fixtures for a total of 59 fixed units draining to the sanitary building drain. Okay, so sizing our branch, all of the trap arms would be 3-inch. Again, those are minimum sizes from table 2493. Immediately at the point where we pick up 3 water closets, we would have to comply to minimum 4-inch for serving water closets. Once we size to 4-inch, we're okay up to 180 fixed units. So certainly the rest of this branch would be okay at 4-inch. Depending on the location of our clean out, if there was a floor clean out here, might be able to pick up that 4-inch line. If the clean out is above slab on this vent, let's say, that we need to get 4-inch all the way to that point. But for minimums, disregarding clean outs at this point, we could say, maybe 3-inch for this part of that fixture drain. If the clean out needed to be something we'd need to provide for this branch, then we'd need to get 4-inch to that clean out as well. So minimum hydraulically would be 3-inch for this fixture drain. Depending on the location of a clean out, might need to go 4-inch to the clean out. Okay, well, we'll stay with 3-inch at this point. 3-inch for all the trap arms as well. 4-inch for the main branch. 4-inch where it connects to this vertical branch. The fixture drain wet vent would be sized as a wet vent because, again, it's directly serving that flush tank water closet. And looking at the wet vent table, serving water closets, minimum 2-inch for this wet section, 3-inch immediately below the water closet, and the trap arm for the water closet is 3-inch as well. And then the building drain is specified at 1 in 100. So for 1 in 100, looking vertically down, we're trying to accommodate 59 fixed units or greater. The first available column is for 4-inch, and we're 4-inch upstream, so no unnecessary or non-compliant reduction, I guess we could say there. So 4-inch for the building drain, 4-inch for the branch, and 2-inch for the wet vent. Okay, so there's all our drainage piping. Now we'll look at names for the vents, and the circuit vent's fairly obvious, connects to the most upstream trap arm on the circuit, and it's going to tie in with this continuous vent. So this continuous vent serves the wet vented group right here, the fixture drain wet vent, serving the water closet. So we know that serving a water closet, right away we're going to need to meet minimum sizes of 1.5 inches, but we'll size it on length of load as well, just to make sure that we don't need to be larger for any reason. And again, to satisfy table 2571, really all of these vents would be minimum 1.5 inches. Okay, let's look at sizing these vents on length and load. The circuit vent, lower end is where it connects to the branch. Upper end will be a major vent or open air. We're going to tie in with this continuous vent to become a branch vent, but that's not a major vent. We would be stopping our length if we tied into a stack vent, vent stack, or vent header. If you don't tie into a vent stack, stack vent, or vent header, then we go to outside air. So we're going to go 2, 4, 6, 26 meters in total for our continuous vent. The load on a circuit vent is the load at the most downstream circuit vented fixtures connection. We said we had 54. So 54 fixture units is what would be included. We do not include anything that drains to what's acting as our wet vent. So 54 fixture units is what's included when sizing our circuit vent. We don't include any fixtures that drain to what's acting as our relief vent. So 54 fixture units on a 26 meter length. Table 2583 used for sizing circuit vents. The total load, we're not exceeding 60. For lengths up to 15 meters, we could have been 2 inch. We're exceeding that, but we're not exceeding 120 meters, so that'll need to be 3 inch. At least that size all the way to open air so that we don't have a non-compliant reduction in our venting sizes. Okay, so we've got that based on length and load, it's 3 inch. Definitely going to satisfy table 2571 as well. Now just to double check we got this continuous vent size correct. The continuous vent lower end is the wet vent. Upper end is major vent or outside air. So the continuous vent for sizing purposes is 21.5 meters. Again, it's sized from table 2583. The load is the load of all fixtures being served by the continuous vent. In this case, all we need to include is the lab and the flush tank water closet directly, so that's 5 fixture units. So for no more than 8 fixture units, no more than 30 meters, 1.5 inches for the continuous vent. We knew that that was going to be our minimum anyways, so we use 1.5 inches for the continuous vent, 3 inch for the circuit vent at this point. Now we'll size the branch vent. Branch vent's lower end is its most distant drainage connection. So as you work your way down into the system, we're going to find our way all the way back to the circuit vented trap arm up here. That's the lower end of a branch vent for sizing, the most distant drainage pipe. Upper end of a branch vent will be major vent or outside air, and we're counting meters as we go. So for the purpose of sizing in the branch vent, we also have 26 meters. We're including more load now though. We have a total load of what's on the circuit vent plus what was being served by the continuous vent. So we have a total load of 59 fixed units. Table 2583 is also used to size branch vents. So no more than 60 fixed units. Our length was 26 meters, so we're going to look at up to 120 meters. And again, we're 3 inch for that as well. So 3 inch circuit vent, 1.5 inch continuous vent acting as our relief, being served by a 3 inch branch vent.